Greetings and welcome, friends, and all subscribers named Emily. We're going over last night's homework. We were talking about solving radical equations, and this is on page 307. So here's question 17, because that's a nice, that's a prime number there, even 17. So it says, solve each equation. Be sure to check for extraneous solutions, which, by the way, occur when you do the whole problem right and then still the answer's just not good enough for the problem. So you kind of have to like plug it back in and find out like, is this still going to work? Because sometimes it just doesn't work out. It's going to be okay though. It's going to be okay. So let's see. Here's our problem. 7 plus 6n square roots of 5 equals 0. Now, I wouldn't actually necessarily classify this really as like a radical equation. This has a radical in it, but the variable's not in the radical. So to solve this, we're going to isolate the variable. So we'll subtract 7 from both sides, and then we'd have 6n square roots of 5 equals -7. And the n is being multiplied by 6 and by the square root of 5. So I could get rid of the 6 by dividing both sides by 6. But better yet, it's also being multiplied by the square root of 5, so I could get rid of the square root of 5 by dividing both sides by the square root of 5. So we might as well, let's just divide both sides by the 6 square roots of 5 simultaneously, right? Simultaneously, even. So n is equal to, and you might be like, wait a minute, this done there does have a radical in the denominator. We've got to get rid of that. So how do I get rid of a square root of 5 in the denominator?
By square root of -5.
Square root of 5 over the square root of 5. I don't have to use any conjugate stuff because this was a single term, little monomial sort of thing. So up top I'll have -7 square roots of 5. Down on the bottom I'll have 6 times root 5 times root 5 is 5. So the bottom is just going to be 30. And that would be the answer. So this problem didn't necessarily have too many interesting things going on in it, just because the variable wasn't actually under the radical. All right, so which is what the next couple examples will look like. And actually, I'm not worried about extraneous solutions here in the way this will all work out, but it'll all be good. Specifically because there wasn't the variable in the bottom or in the radical or anything like that. So let's see, number 19. This says the cubed root of 2p plus 1 is equal to 3. And it's the entire 2p plus 1 as indicated by the vinculum covering up the entire expression there. Now, the thing that I've got to get rid of first to get this variable by itself is this cubed root. And what do you think I could do to invert that or to undo cubed rooting? What's the undo going to be?
Cube everything.
Cubing both sides is a mathematically allowed move, and cubing would kill off a cubed root, right? So this would end up being 2p plus 1 is equal to 3 cubed is 27. Remember, that doesn't mean 3 times 3, that means 3 multiplied by itself total 3 times. And now this looks like just a vanilla problem right here. So 2p equals 26, and then divide by 2, divide by 2. And I get p equals 13. And let's do a little check here just for funsies. And by the way, when we do a check, I have to plug the answer into the original problem, not one of my like modified ones from later on in there, because then that's not really checking to see if it works. So is the cubed root of 2 times 13 plus 1, is that equal to 3? So the cubed root of 26 plus 1, cubed root of 27. Is it lagging out on me? There we go. I think I just had like 10 seconds of video lag there. And this is equal to 3 for sure. No problems there. So cha-ching. And remember, when you're also doing a check, you're just following PEMDAS, so don't redo any algebra steps. All right, when you're doing a check, because you might do the same step as you did before, and then you're not actually checking to see if it works because you might have duplicated the process. Let's see, I think I've got this next one hiding over here. Whoa, it's all over the place. Don't lag out on me, computer. So here we go. Problem 25. 3 plus the square root of 4n minus 5 equals 10. And now this is more like a true, bless you, classic sort of radical problem. And typically what I'd recommend is step 1, isolate the radical. And then in this case we would square both sides. As a general procedure. So I don't want to square both sides now.
You gotta subtract.
Because if I squared both sides now, I'd end up having to I can't remember, it's illegal to distribute a square over addition. So yeah, I would just get real ugly fast. I'd actually have to use a pattern. So let's subtract 3. Let's get this radical by itself first. So the square root of 4n minus 5 is equal to 7. And now that the radical is isolated by itself, right, I can't access any of the stuff on the inside until I deal with this radical part.
You can divide by 4n minus n 5. Or you can do that.
Yeah, I want to square both sides in order to, right, cancel out, right, the square kills the square root, right, because there's a little invisible index of a 2 there. So we would end up getting 4n minus 5 equals 7 squared is 49, and then we would add 5 to both sides, and now this is like just a classic little algebra problem here. 4n is equal to, what's that?
54.
54. My goodness. And then divide by 4. Is that going to equal 27 halves, I believe? Because 2 goes into both of those, yeah. I believe so. Now, there's a chance that even though I did this problem correct and I followed the right procedure, that this answer still is just not good enough. And it's like, what the heck? I did everything right. I don't understand. Right? It's okay. It's going to be okay.
Extraneous.
So it could be extraneous. I'm not sure, actually. I don't have the answer in front of me. But let's do a proper check here. So I'm going to do 3 plus the square root of 4 times n. N is the 27 halves. And then what was it? Minus 5 equals 10. So let's see if this works out. So 3 plus the square root, 4 times 27 halves. Well, 4 divided by 2 is 2. 2 times 27, 54. Minus 5 equals, that's 3 plus the square root of 49. That's 3 plus 7. That's equal to 10 if I ever heard it. And that's a cha-ching. All right, so it's possible if this for some reason didn't work out, if I ended up having like 3 plus a negative 7 or something weird like that, then it would not be true and I'd write extraneous. And if it happened to be the only solution that was possible and it was extraneous, then I would say that there was no solution to the overall problem. All right, so thanks for watching, Internet friends, especially ones named Emily. Bye-bye.